If you're learning about molecular orbital theory, or MO theory for short, you are probably seeing a lot of MO diagrams. Let's analyze one of these diagrams piece by piece. In an MO diagram, you will inevitably see an energy scale on the left side. The arrow is always directed pointing upward. And is usually marked a little e like this to indicate higher energies. Now there's something to be careful about when looking at these MO diagrams. Higher up on the arrow means less stable, while lower in the diagram means more stable. So let's keep that in mind looking at our MO diagram. Next in the MO diagram, you will see these little short horizontal lines. These little short horizontal lines represent either an atomic orbital, the ones on the outer edges, or a molecular orbital, the ones on the inner edges. You also see these little horizontal lines connected by thinner lines or dashed lines. We'll think about why those lines are there later. But it's important to keep in mind that in the middle of the diagram we have our molecular orbitals, everything lined up in the middle. Whereas on the outer parts, on the left side, say, we have our atomic orbitals. Here we only have one on the left side. And then we also have atomic orbitals on the right-hand side. We may even see graphical representations of these atomic orbitals. Here we're looking at hydrogen. So these are the hydrogen 1s orbitals. And we will also frequently see a graphical representation of the molecular orbitals, positioned in the middle of the diagram. The MO diagrams tell us how molecules bond. And as such, this means we are thinking about electrons interacting with one another. So I've just drawn a handful of electrons, and the way I've drawn them indicates what spin they are. So arrows pointing upward are upspin electrons, like the one on the right here in the atomic orbital. And electrons that are pointing down are downspin electrons. Notice that we never see two electrons of the same spin, both spin up or both spin down, in the same orbital. This is important if we want to obey Pauli's exclusion principle. Now, went back to these little dashed lines. What do those lines tell us? Well, they tell us what atomic orbitals a molecular orbital is made from. So what does that mean? Well, it means that if we look at the molecular orbital, say on top of the diagram, this molecular orbital here, we can use these lines to say, okay, that is made out of this orbital, this atomic orbital, and this atomic orbital. They were mixed together to make that one molecular orbital. Now let's keep in mind these little circles that I've drawn represent either an atomic orbital or molecular orbital, where this one here is a molecular orbital, whereas the one on the side would be an atomic orbital. And finally, we can think about the phase of the orbitals, either plus or minus phase. So we might see colors represent that. Red for one phase, blue for another phase. And that is our MO diagram.